Hello, in this video here, we'll be finding the gradient at a single point using the derivative. So when we talk about the gradient at a single point on a curve, usually what we would do is sketch it out, then we would draw a tangent line, and then we would try to find the equation of that tangent line. We can visualize that perhaps in the next video where I can go through some of these questions here using the CAS calculator. So in this first question here, what we want to see, we see that it talks about the gradient of the curve. It's asking us to find the gradient curve, which is mt. M stands for the gradient, T stands for the tangent at that curve. And here is our equation, our original equation. And it's also given us a point where we want to find that specific gradient. So how do we visualize this here? There's a little diagram that I like to use that shows us the connection between the x value, the y value, and the gradient. We will see that the x value is the intermediate connection between the y value and the dy dx, which is our gradient value. Since we have the original equation, what we can do is we need to find the gradient of the curve. And if we're finding gradients, then it is the derivative dy dx. This gives us our gradient at any single point. So we're going to differentiate this first. And then we need to also plug in this information that we have here. Now, if we look at the formula for our gradient, we have dy dx, which is the gradient, and we have the x variable. So out of these two variables here, or the coordinates, the only value that we need to use is the x value. I'll use this diagram here to illustrate that further. We can see the x value is 2 based off the coordinate, and the y value is 26. For a direct connection, we can't find dy dx using our y value. We only have a direct connection from x equals 2 to get to our gradient. So we can see it goes in that direction there. So for us to find our gradient, we need to substitute in x equals 2. And so we can find our derivative. So 8x cubed minus 3, we're going to substitute that 2 in. (64 minus 3 is 61. So that means that the gradient at that single point at x equals 2, or the coordinate 2 and 26, the gradient is 61. Now, in the next example here, the calculation is already done. You can see here that I'll just talk through this here. So the gradient of the tangent is mt. We need to find what mt is. We've got the equation or the rule, and we also have the domain. And it's at the point 1 and 2. So if you have a look here, I've only labeled the x. We also have the y value as well. So just using this little diagram, we can see that our y value is 2, our x value is 1. But if we want dy dx, which is the same as the gradient of the tangent, we need to use our x value. You can see, here's our original function. I've just rearranged that like so. So it's in a differentiable form. Then we find the derivative. I bring the negative power down into the denominator, because if I want to find the gradient, I need to substitute x equals 1 to find dy dx. Now, notice this notation here. We can write y and dy dx, but in this here, it's f of 1 equals 2. And for this dy dx here, we would say f dash of x. But we know our x value is 1. And so we will evaluate to a value of 2 after we substitute it in. So have a look at the notation and how it differs from when we have y equals versus when we have f of x in function notation. Now, if you find this diagram a bit confusing, essentially it's just a summary. It helps you keep a roadmap or a summary of everything. But x is the central piece. It connects the y value and the gradient. And you can draw the arrow in whichever direction you need to go. In this example here, you can see f of x. They want us to find the gradient of the tangent, so f dash x. And they've given us another point, so by now we understand that we only need to use our x value. We don't need to use the y value. It's a red herring. So we find our derivative, and we substitute the x value, which is x equals 1, like so. Replace the x value with a 1 there. Our gradient at x equals 1, therefore, is -3. Last but not least, again, we're finding the gradient of the curve. There's an x outside here, so I expanded that into the bracket. Here's a simplified expression. Notice this is still the original equation. You find the derivative, and then you make the powers positive by taking the derivative, the negative power, into the denominator. Once you've got that, then you can substitute x equals 1 into the equation to find your gradient. So the gradient is equal to 5. That's pretty much it there. So with those 4 examples, I highly recommend that you annotate the question, underline, annotate, and tag these little values here, these little notes on the question if you can. Okay, so don't forget to pause the video, rewind and rewatch if you'd like to revise.